Welcome to the course on reliable distributed algorithms. We will start the course with an introduction to distributed systems. It is an introduction to distributed system, and I am Saif Haridi. So what is a distributed system? One way to look to distributed system is to see what an expert in the area has said. And this expert is Leslie Lamport. Leslie said the following: a distributed system is one in which the failure of a computer you didn't even know existed can render your own computer unusable. Leslie has contributed a lot to the theory and algorithm of how to build reliable systems. He is also the Turing Award winner of 2014. The point that he really wants to make is that the service in your computer may depend on other computers somewhere else in the network. If something happens to one critical machine, the service might not be able to run. If a computer coordinates a file system, for example, by storing the metadata of the system, and if that machine fails, the service on your local computer and also in other client's computer might stop. But the issue is, what is really a distributed system? A distributed system is a set of nodes connected by a network which appear to the users as a single coherent system. So here is one example. You can draw a system like this. That's the network. And you have a set of nodes. We call them P1 ... to Pn. And these systems communicate by sending messages. The nodes send message to each other. So we have a send for sending messages, and nodes can receive messages. And the only way for these nodes or processes to communicate is through sending and receiving messages. This computer could be a local computer, mobile devices, servers at a data center, etc. These machines can only communicate through the network by sending and receiving messages. We will mainly abstract this notion of physical machine and only talk about processes. A process can be a server, a computer, a mobile phone. So what is the focus of this course? We are going to focus in this course on concepts, models, and given a model, and what we mean by a model here is a model for a distributed system. We look to which problems are solved and which are not solved on that model. What are the core problems in distributed systems? What are the algorithms to solve these problems? And how we are going to reason about correctness of these algorithms. And in fact, we'll also cover how you program these systems, how you program these algorithms to build a distributed application, a distributed service. So why do we study distributed system? It is important and useful. In fact, distributed systems are everywhere nowadays. The Internet is a distributed system. The World Wide Web is a distributed system. Cloud computing, set of data centers, is a distributed system, and computing on the edge of the network using small devices and sensors is also a distributed system. The Internet, it's a network of computers called routers that deliver messages to and from the edge nodes. Could be my computer, your mobile device. Edge computing, on the other hand, is where a lot of devices, smartphones and sensors are connected through a wireless network to the internet. A data center, which is part of cloud computing, provides service 24 hours, 7 days a week, like for example those data centers hosted by Google or Facebook. And the data center provides storage and computing resources to service millions of users. This is done by using distributed system, a set of machines connected by a network. Here is an example of some data center. There is another reason to study distributed system, and that is because there are also technical issues that we study distributed system for. For example, scalability. Scalability is the use of a network of servers to serve multiple users. Imagine a service that is servicing requests from hundreds of thousands of users or even millions, and you want to provide such a service. You cannot do that in a single computer. You have to use a large number of machines connected together to do the task. Reliability is another issue where you would like to replicate the same service on multiple machines, so if some fail, the other will carry on. There's also reasons for distributed computing when your resources, your computing resources, are distributed. For example, in a geographic distribution. This could be a peer-to-peer network or a sensor network or just even a set of data centers connected together. So why do we study distributed systems? Distributed systems are challenging, and the reason for this is that you have to study two aspects. One is partial failure and the other is concurrency. Partial failure means that you have these nodes connected with a network, and some of the nodes might fail, or some messages could be dropped, or the network could be partitioned, but still the system as a whole has to work to provide the service. Another aspect is concurrency. Distributed system really is consisting of number of processes executing in parallel, and that is parallel or concurrent programming. So distributed system consists of both parallel computing and partial failures. This together makes it more challenging. When we study distributed system, we encounter a series of recurring problems. Some of them are easy to solve and some are hard, and some are impossible to solve depending on the model. All these depending on what kind of system we're talking about.